أهلا وسهلا بالجميع. محاضرتنا اليوم بعنوان Transformation of Random Variables. Let x be a random variable with a given probability mass function, probability of x equal x if x is discrete, or a probability density function if x of x if continuous. Let y equal g of x be a single valued function of x. Then y is a random variable. The objective is to find its probability mass function or its probability density function. يعني بيعتمد على نوع distribution إذا كان discrete or continuous. So this is the setup of the problem. X is a random variable. X could be discrete or it could be continuous. So it's fully characterized in terms of its probability mass function or its probability density function. The random variable x undergoes a transformation y equal g of x. Now, x is a random variable, and a function of a random variable is also a random variable. So the objective of this lecture is to find the probability mass function of the random variable y if x and y are discrete, or the probability density function if x and y are continuous. So this transformation, we are assuming that this transformation y equal g of x does not change the nature of x. So if x is discrete, the output would be discrete. If x is continuous, then y would be continuous. And ناخد بعض الأمثلة على الديسكريت ديستريبيوشن وكيف بنعمل ترانسفورميشن. ففي عندي مثالين بدي أعرض لكم إياهم كيف بنوجد البروبابيلتي ماس فانكشن لما يكون في عندنا ترانسفورميشن. An example on discrete random variables. An intercom system master station provides power to 3 offices. The probability that any given office will be switched on and draw power at any time is 0.4. When on, an office draws 0.5 watts. Find the probability mass function of the power drawn by the intercom system. Find the mean value of the power delivered by the master station. So this figure demonstrates the problem. We have a master intercom unit, and it provides power to 3 offices. These offices are switched on and off independently of each other. And when an office is switched on, it draws 0.5 watts of power, and the probability that this office is switched on is 0.4. The same applies to the second office and also applies to the third office. So these offices are identical in terms of their probability of success. Here what we call it success in terms of the binomial distribution. So the probability that the office is switched on, we call it probability of success with probability 0.4, and we have the number of parameters for x is 3. That is, we have 3 independent offices. So let x be the random variable representing the number of on offices. We have 3 offices. We might have all of them switched off. In this case, x is 0. That is the number of offices that are switched on. We might have one of them switched on, either 1 or 2 or 3. So in this case, x is 1, and we might have also 2 offices without regard to the order. So the offices could be 1 and 2, 2 or 3, or 1 and 3. So this is x equal to 2, and we may also have all of them switched on. In this case, x equal to 3. So if x is the number of offices that are switched on, and offices are switched on independently with the same probability 0.4, then the number of offices which are switched on follows the binomial distribution, probability that x equal n choose x, p to the power x1 minus p to the power n minus x, and as I said, p equal 0.4 and n equal to 3. So the probability that one office or all offices are switched off, this means that x is 0. So in this case we have 3, choose 0, p to the power 0, 1 minus p cube. This is the probability that x is 0. If x is 1, we have one office on, then probability that x equal 1 equal 3, choose 1, p to the power 1, 1 minus p square. 3p, 1 minus p square. If x is 2, then n, choose 2, p square, 1 minus p. 3p square, 1 minus p. This is for x equal to 2. Finally, when x is 3, we have 3, choose 3, p cube, 1 minus p to the power 0, and this is the probability mass function of x. So far we have found the probability mass function of the random variable x. X assumes the values 0, 1, 2, and 3, and the probability mass function of x follows the binomial distribution. So we have a probability associated to each one of these 4 values. Now x undergoes the transformation, which is like this. Now when an office is on, that office draws 0.5 watt. So if none of the offices are switched on, then the power drawn by the master station is 0. If one of these offices is on, then the power drawn is 0.5 watt. If 2 are drawn, if 2 are switched on, then the power is 1 watt. And if all of them are switched on, then the power is 1.5. So the relationship between the input and output is like this: y equal 0.5x. X is the input random variable, y is the output random variable, and this is the transformation constant, 0.5x. So this is the relationship between the input and the output, and it's a linear relationship. So if we need to find the probability that the power drawn is 0, so if the power is 0, then this only occurs when all offices are switched off. So the probability that the drawn power y equal 0 is when all offices are shut down, that is when x equal to 0. So the probability that y equal to 0 is 1 minus p cube. Now the probability that y is 0.5, y is 0.5 when x is equal 1. So in this case, the probability that y equal 0.5 is the same as the probability that x equal 1 and equals this probability. And we have 1 watt drawn when two of the offices are switched on, so the probability that y is 1 what? When two offices are switched on, that is when x equal to 2, and the probability that y is 1 is 3p squared 1 minus p. Finally, y takes on the value 1.5 with probability equal to the probability that x equal to 3, and that is p cubed. So this is a simple example that demonstrates the transformation for a discrete random variable. So the whole idea behind this kind of transformation, that we are given a random variable x with a known probability mass function, and we are given some transformation function y equal g of x, and the objective is to find the values of y along with their associated probabilities. So this is what we mean by a transformation of a random variable. That is, we need to find the probability mass function of y, which means when we say the probability mass function of y, this means that we need to identify the values taken by y along with their associated probabilities. في عندنا كمان مثال على discrete random variable. So the DC current X that flows through a 1 ohm resistor R is a discrete random variable with the following probability mass function. Probability that x equal 1 over 6 for values of x between -3, -2, -1, 0, 1, and 2. So x has this probability mass function. These are the values assumed by the current pulses: -3, -2, -1, 0, 1, and 2. In this problem, the current source randomly switched on or is switched on between any of these values of the current with this probability. So this is a uniform probability over all values of x, and we have this DC current emits or generates a random current according to this distribution. Now, since R equal 1 ohm, we have this relationship between the power and the current. The power P equal I square R. I, we have replaced I, the current, by x square, and R equal 1. So the power that is dissipated in the resistance R equal x square. So Y is the power in units of watt, and X is the current. X takes on these discrete values, -1, 0, 1, and 2. So the problem that we are about to address is find the probability mass function of the power in the resistor. So we need to find the probability mass function of Y, and we need also to find the average value of Y, that is the average value of the power. So in this case, these are the values of X, and we have this transformation Y equal X square. Okay, so X assumes values -3, -2, -1, 0, 1, and 2, and so the values of Y are equal. When X is -3, Y takes on the value -3 squared, so Y is 9. So when X is -3, Y is 9. When X is -2, Y is 4. When X is -1, Y is 1. When X is 0, Y is 0. When X is 1, the square of 1 is 1, So that is 1 again. And when x is 2, y is 4. So we look at the values of y. We have 0, we have 1, we have 4, and we have 9. So x assumes 6 values, y takes on only 4 values. However, the probabilities over the values of y are not uniform. So y takes on the value 0 only if x takes the value 0. So the probability that y equal to 0 is the same as the probability of x equal to 0, and this equals 1 over 6. The probability that y equal 1 has 2 sources. Y equal 1 results when x is minus 1 and when x is 1. Both of these two values of x minus 1 and 1 lead to one value of y, which is 1. So the probability that y equal 1 is the same as the probability that x equal minus 1 plus the probability that x equal 1. So we have this probability for y equal 1. The probability of y equal 1 is 2 over 6, which is the probability that x is minus 1 plus the probability that x is 1. As for the probability that y equal to 0 is the same as the probability that x is 0, and this equal 1 over 6. The same when y is 4. Y equals 4 is a result of x equal minus 2 and also x equal 2. So there are two sources for y equal 4. The first source is when x is 2, and the second source when x is minus 2. So the probability that y is 4 is the probability that x is minus 2 plus the probability that x is 2, and the probability that y equal 4 is 2 over 6. Finally, x minus 3 leads to a value of y equal 9. Y equal 9 is a result only of one value of x, which is minus 3. Therefore, the probability that y equal 9 is the same as the probability that x equal minus 3, and this equals 1 over 6. So the answer to the first part is find the probability mass function of the power in the resistor. This is the probability mass function. We have values of power 0, 1 watt, 4 watts, 9 watts, and the probability of 0 is 1 over 6. The probability of 1 is 2 over 6, 4, 2 over 6, and 9, 1 over 6. So we have 4 values for the random variable y, and these are the probabilities associated with the values of x. The second part is find the average power dissipated in the resistor. So we need to find the expected value of the power, and we know how to find the expected value of a discrete random variable. We multiply each value of y with the corresponding probability. So it's 0 times 1 over 6, 0 times 1 over 6, plus 1 times 2 over 6, plus 4 times 2 over 6, plus 9 times 1 over 6, and the result is 19 over 6 watts. So these two examples demonstrate how we find the probability mass function of a discrete random variable that undergoes a given transformation y equal g of x. الآن بنيجي للجزء الثاني من المحاضرة how to find the probability density function of a continuous random variable. So this is the continuous case. Let y equal g of x be a monotonically increasing or decreasing function of x. What we mean by a monotonic function is a function which is strictly increasing or strictly decreasing, that is, a function for which the derivative is not zero. If the derivative is zero, this means that the function at some points will be constant. So we are avoiding this situation where the function is constant. So our function or our transformation has a condition that the function or the transformed function y equal g of x is either increasing or decreasing. This is an example of a monotonic function. As x increases, y increases. So the derivative in this case is always larger than zero, positive. So this is what we call a monotonic function. For this monotonic function, in order to find the probability density function of y, we look at this figure. الآن the probability that x takes on the values x plus delta x, that is, x falls within this differential distance. This is the same, because of the monotonicity of the function, this is the same as the probability of y falling between y and y plus delta y. So we have this relationship that x falls between x and x plus delta x is the same as the probability that y falls between y and y plus delta y. So we have now this fundamental relationship, that is the probability that x is between x and x plus delta x is the same as the probability that y, the random variable y, falls between some value y, which corresponds to x, and y plus delta y, which corresponds to y of x plus delta x. Okay? So this is the fundamental relationship. Now, what is the probability that x falls between x and x plus delta x, that is, within a differential length delta x? Now, we recall the definition of probability for a continuous random variable. That is the probability that x falls between a and b. The probability that x falls between a and b is the area under the curve. So we can substitute the limits x or a and b. So this is fx of u du. So in general, the probability that x falls between a and b is the area under the probability density function from a to b of f of x dx or fx of u du. However, when b becomes very close to x, in this case we have this x and x plus delta x, we can approximate this integration by the area under a rectangle with height f of x and width delta x. So this is an approximation. This is an approximation of the probability that x is between x and x plus delta x. It's the area under the probability density function, and the probability and the area under the probability density function can be approximated as the height of the curve, which is f of x, times the width of a rectangle with differential with delta x. So here طبعا احنا بنعرف ال density function, so f of x is a known function. فهي احنا وجدنا ال probability of x between x and x plus delta x. الآن بدنا نوجد the probability that y is between y and y plus delta y. Similarly, because of, again, of the monotonicity of the function, this probability that y falls between y and y plus delta y, that is within a differential length delta y, is the probability that y between y and y plus delta y, again, is the area under the unknown probability density function f of y. This is unknown. This is a known density function f of x. So again, this area, this probability is approximated by this area, which is the height of a rectangle of width delta y. So this is the area of this differential rectangle. Now again, we make the substitution on the right hand side. So the probability that y is between small y and y plus delta y, f of y delta y, probability that x between x and x plus delta x, again, is f of x delta x. Now this is known, this is known, this is unknown, fy of y. So fy of y is fx of x times delta x by delta y, or equivalently fx of x divided by delta y by delta x, and in the limit as delta x goes to 0, this delta y by delta x becomes the derivative dy by dx. And what is dy by dx? Remember that y is the function g of x, that is dy by dx is the derivative or the slope of this function g of x. So this is x, this is y is g of x. وهنا ببين عنا the reason why we require the function to be monotonically increasing or decreasing, so as to avoid dividing by 0. If the function is constant at any point, then dy by dx is 0, while the function fy is not defined. So now this is the formula that we need to use in order to find the probability density function of a continuous random variable y in terms of the known probability density function f of x and the derivative of the transformation y equal g of x. خلينا نشوف مثال بالأول. The amount in dollars charged by a technician is related to the time x in hours needed to complete a task by the relationship y equal 10x plus 20. So this is what the technician earns, and this is the amount of hours, and this is a constant. This is the base, this is the base charge. This is the base charge, $20, and he charges $10 for each hour that he spends. So the time x needed to complete a task is a random variable which follows the exponential distribution. So this time x is a random variable which follows this exponential distribution lambda e to the minus lambda x for x larger than 0 and 0 for x less than 0. So we know x is a continuous random variable. We know the probability density function of the random variable x. Y is the transformed random variable, and the objective is find f sub y of y and the region over which it is defined. So the first objective is to find the probability density function of the new random variable y, representing what the technician earns, and this is 10x plus 20. Part B, find the mean value of y. نجي لها كمان شوية. So this is the graph which relates x to y. We have this relationship. This is the curve y equal 10x plus 20. When x is 0, y equal to 20. And when x is infinity, y also goes to infinity. So x as a random variable changes between 0 to infinity. However, the random variable y changes between 20 and infinity. Between 20 and infinity. The minimum value of y is 20, and this happens when x is 0. So this is the region over which the new density function y is to be defined from 20 to infinity. نطلع على الكيرف y equal 10x plus 20. It's a straight line, so it's a monotonic function. Its derivative is larger than 0. So all conditions which we impose on the transformation are applicable to this curve. فبنبدأ بنقول y equal 10x plus 20. This is a monotonically increasing function. Now we use this fundamental relationship f sub y of y equal the density function f of x divided by the derivative dy by dx. The derivative dy by dx equal 10. And here we have taken the absolute value, and this is to account for monotonically increasing as well as monotonically decreasing function, since the density function f of y cannot be negative. So if the transformation is, or if the function that undergoes the transformation is monotonically decreasing, then the derivative is negative. This means that f of y is negative. So we avoid this by taking the absolute value dy by dx, and this ensures that f of y is positive. So the derivative dy by dx equal 10. Okay? Now f sub y of y equal f sub x of x divided by 10. But x is y minus 20 over 10. So بدنا نتذكر إنه the left hand side is a function of y. The right hand side is a function of x. So we need to replace x with y. So this is the reason. So x equal y minus 20 over 10, which means that fy of y equals the density function f of x. Instead of x, we make the substitution y minus 20 over 10 divided by 10, and we take this function now, lambda over 10 e to the minus lambda, and instead of x, we substitute y minus 20 over 10, and instead of x again, we substitute y minus 20 over 10 larger than 0. So the density function of y equal lambda over 2 e to the minus lambda y. Now it appears as a function of y minus 20 over 10 for values of y larger than 20 and 0 for y less than 20. So this is how we do the transformation. We need first to identify the density function of x. we need also to find the derivative of the transformation. And the third step is to relate x by y, that is, make the substitution in the density function so that it becomes a function of y rather than a function of x. الخطوة الأخيرة, we need to find the mean or expected value of y. So the expected value of y, we know this relationship that the expected value of 10x plus 20 is 10 times the expected value of x plus 20. وفي محاضرة سابقة احنا we studied the exponential distribution and found that its mean value is 1 over lambda. So expected value of the exponential distribution is 1 over lambda. So this is the expected value of the income per job of this technician is 10 over lambda plus 20. في عندنا كمان مثال. The profit Y of a manufacturing plant is related to the demand X by the relationship Y equal AX plus B. Again, this is a linear transformation. Let X be a Gaussian random variable with mean mu X and variance sigma X squared. The objective is to find the probability density function of Y. So again, we use the fundamental relationship that the density function of y is the derivative f of x by dy by dx. dy by dx is this constant a. Now we don't know if a is positive or negative, so we take the absolute value of a. And making the inverse solution, so x in terms of y is y minus b divided by a. الآن الدensity function fy of y equal the density function of x, which is 1 over square root of 2 pi sigma x square e to the minus x minus mu x square over 2 sigma x square. This is the density function of x, and this is the derivative dy by dx. الآن بنشوف إنه the left hand side is a function of y. The right hand side is a function of x. So we need to have everything on the right hand side in terms of y. So we need to use this relationship x equal y minus b over a. طبعا هنا هدول these are all constants that do not depend on x, فبضلوا مثل بعض 1 over 2 pi. بس اللي عملته هنا a دخلتها جوا الجذر التربيعي فصارت 1 over 2 pi a sigma x square e to the minus, instead of x we make the substitution y minus b over a minus mu x square over 2 sigma x square. في شوية manipulation. This is the same e to the minus y minus b minus a mu x all square all divided by 2, and this a square goes down a sigma x square, and it can be written in the form 1 over square root of 2 pi a sigma x square a sigma x square. So we call this sigma y square. So we have 1 over square root of 2 pi sigma y square e to the minus y. This is the mean value of y square over 2 a sigma x square sigma y square. So the result is a Gaussian random variable. So x is a Gaussian random variable with mean mu x and variance sigma x square. Y is a Gaussian random variable. So therefore y ax plus b is Gaussian with mean زي ما احنا شايفين. The mean of the random variable is b plus a mu x, b plus a mu x, and variance a sigma x all square, a sigma x all square. And then we have the result, and this result we will prove in the next chapter, that a linear transformation of a Gaussian random variable leads to another Gaussian random variable. هذا مثال تاني على transformation of continuous random variables. يعني continuous random variables, we have to use this equation. في عندنا steps, define the density function of x, define the derivative, make the inverse substitution, and in this case you will have the answer in terms of y. في عندنا كمان مثال. Let x be a Gaussian random variable with mean 0 and variance 1. Define y equal x squared. We need to find the density function of y. So y equal x squared, y equal x squared is not a monotonically or strictly monotonically decreasing or increasing function. So for the positive part of x, it's an increasing function. For the negative part of x, it's a decreasing or monotonically decreasing function. So how do we find the probability density function of y? Now, x as a random variable takes on all values from -infinity to infinity. And when you square x, you end up having only positive values. So y varies between 0 to infinity. So y is non-negative. However, x can be any value from -infinity to infinity. الآن بنطلع بنشوف نفس النتيجة. So the probability that y falls within this differential length delta y is the same as the probability that x falls within this differential length delta x for the positive part, plus the probability that x falls within this negative part. Now when you square the negative, you end up with this positive, and when you square this positive, you have also this positive. So we can get around this difficulty by finding that the probability fy of y delta y is twice the probability that x falls between x and x plus delta x. So again, dy by f of y equal twice fx of x delta x over delta y, or twice fx of x divided by dy by dx, and in the limit when delta x goes to 0, we have dy by dx, which is the derivative of this curve, and we take the absolute value. So for this problem, the only difference between this problem and the previous two problems is this factor of 2. And this factor of 2 came as a result of having positive as well as negative values of x contributing to the same value of y. فالآن نيجي للمسألة. We have the transformation y equal x squared. The derivative equal to 2x, and we take the absolute value of x because x can be positive or negative. And f sub y of y, this is f sub x of x, this is a Gaussian random variable with mean 0 and variance 1. So this is the density function of x, 1 over square root of 2 pi e to the minus x squared over 2. And this 2 is a result of the equation which we derived. The other 2, this is 2x, this is the derivative 2x. بنعمل substitution, we take only so that y is positive, so x equals square root of y, we take only the positive root, So fy of y, this 2 cancels out with 2, this 2, so we have 1 over square root of y, 1 over square root of 2 pi e to the minus, instead of x square, we substitute y, and so the density function of y, f sub y of y equal 1 over square root of 2 pi y e to the minus y over 2, and this is applicable for y larger than 0. فبدنا نشوف إنه in this kind of transformation, unlike the previous example, the density function of y is not Gaussian. يعني when x is Gaussian and it undergoes a linear transformation, y is a Gaussian random variable. However, in this case, y is not a Gaussian random variable. راح نعاود نشوف هاي الدنسيتي فانكشن في مرة تانية لما نحكي عن statistics. So this is another example of transformations of continuous random variable. المثال الأخير اللي بدنا نشوفه شوية tricky. Let x be a uniform random variable in the interval minus 1 to 4. Again, we have a transformation y equal x square, and we need to find the probability fy of y. X is uniform, meaning that the density function of x is constant over the interval of interest, which is minus 1 to 4. So the density function of x is uniform, having this value 1 over 5. It extends between minus 1 and 4. So this is the density function of x. Now we have y equal x square. فنطلع على الكيرف y equal x square. الآن x as a random variable changes between minus 1 and 4. Over the interval from 1 to 4, each value of x leads to only one value of y. So this is a monotonically increasing function, and each value between 1 and 4 of x leads only to one value of y. However, for values of x between minus 1 and 1, two values of x lead to one value of y. So this example is a combination, the solution to this example is a combination of previous examples. So for this part between minus 1 and 1, we use a factor of 2. For this part between 1 and 4, we use only a factor of 1. So for x between minus 1 and 1, f sub y of y equal 2 times f of x divided by dy by dx. So over this part we have this factor of 2, so we have 2 times the density function of x equal 1 over 5, and the derivative dy by dx equal 2x, and this simplifies now x, as we have said earlier, x is just the square root of y, and so we have 1 over 5 square root of y. So the density function for values of x between minus 1 and 1. Now, for values of x between minus 1 and 1, y varies between 0 and 1. So for y between 0 and 1, which is equivalent to the range x between minus 1 and 1, the density function f of y equal 1 over 5 square root of x. Yes, 5 square root of y. For this part, as we said, only one value of x produces one value of y. The probability density function of y, we don't have the factor of 2, so we have f of x over dy by dx, and dy by dx equal 2x, derivative dy by dx equal 2x, and we have 1 over 5 So it's 1 over 10 square root of 10 and 0 otherwise. So for values of y between 1 and 16, which is equivalent to values of x between 1 and 4, when x is 4, y is 16, when x is 1, y is 1. So for values of y between 1 and 16, we have this function 1 over 10 square root of y. However, for x between minus 1 and 1, we have only 1 over 5 square root of 2, and the density function is 0. And you can verify upon integrating f of y between 0 to 16 that this is indeed a valid probability density function. فهاي هي نهاية المحاضرة. يعطيكم العافية وإلى اللقاء.